Hello and welcome to 3D Concrete Competition, where we build the second 3D concrete sculpture in Latvia, definitely, maybe even Baltic states. And this today is the first workshop where we'll also tell you a little bit how we built the first 3D concrete sculpture. And we called it the most loved 3D concrete sculpture because we are quite sure that no other concrete sculpture has received as many hugs as this one have. So hello to all of you on Zoom and also on those who are watching the recording later. So you are now part of this LabLab 2.0 technical design competition. And what it entails, primarily design task, is to offer the most efficient split and assembly solution for the provided 3D model for concrete printing. And why splits is important because later in Mari's presentation, you will see that there is limited size, how big we can print the parts. And also when we assemble it, there is limited weight capacity, how heavy items we can lift with a standard crane. And that's what will be your limitations. And basically you have to divide the geometry in parts and try to put it back together. The total price pool is 2,000 euros before taxes. Yes, before taxes in scholarships. And that's for you participants. And how you will be evaluated, we will look at split design, material efficiency, feasibility and stability, ease of assembly, and any creative additions you decide to implement. I don't know, maybe it's a step, maybe there's like a place where you can put some poster on the sculpture that you can decide later by consulting with the mentors. And we already have two frequently asked questions, which we'll answer directly and right now, which is basically, can you change the geometry? Yes, you can. And can you combine it with polymer and traditional printing methodologies? Yes, that you also can. So that is something you can do. This is roughly how the sculpture or 3D geometry file looks. And if you want to download and explore it for yourself, we will also send the link in the chat so you are not missing out on anything. But it is here in the link, and the design author Lennart Reinis-Rosidis also will join us for some point to explain about it later, but currently you can get the blend file. We can also send you an OBJ file, and if you need to convert it, then the blend file and Blender is an open access software. You easily save it as any other open file format. So something before we begin today's lecture, if you want to know more, because we usually don't try to repeat too much as all of the lectures are recorded, we already had one 3D concrete competition with 3D concrete lectures. It was 2 years ago, and this is sort of a follow-up one. And in that one, we recorded a lot of introductory lectures. So basically how to slice files, how to prepare them, how to optimize geometries, and they are all available. The four maybe kind of the most important lectures I remember were Intro to 3D Concrete Printing from Maris, who is also here today, and also a workshop on 3D concrete printing technology. And two ones that are also quite essential is Preparing Files for 3D Printing by Juris Skļava and Optimization of 3D Printing files, so also from Juris Skļava. And if you want to delve into more advanced topics, then you can look at this 3D concrete print review where we evaluated student designs and also preparing files for 3D concrete printing, as well as 3D construction printing and 3D print dry mix development process. So that's already more advanced topics if you are really competitive and want to be sure that you will be in the first place. Now, those are good places to look for material because in our region there is not that many concrete printers around, not that many know-how or the tutorials haven't yet been made how to use it, and this is currently a good resource to use. So link for those we can also send you, but it is if you go to Creative Tuesdays on YouTube, there is a playlist that is called 3D Concrete Competition. Following up, registrations are still open till tonight, midnight, but we have quite enough participants, so we are not pushing any extra. But if someone forgot to register, then definitely do. Although all of you who are here probably should already be registered. We also have a Facebook group where we just put some ideas that we find out in other countries where there's a great 3D print. So we share those quite frequently there. And I suppose all of you already should be here because this is part of the registration, is that you join the WhatsApp group. But if you haven't, that is basically the main channel of communication. So I will not be sending you emails, but when there is next lecture or there is some update, we will put it on the WhatsApp chat. And also if you have any questions while creating the proposal, you can definitely send your questions there. So the first part of today's lecture is how we designed the first sculpture, and maybe also some learnings and lessons we learned. So the next one is even better. Here is all the team. In the front, you see most of the people who were involved. So we have Lauris here, and Elin, and Maris team, and my team from Creative Tuesdays and Moorburg Studio, as well as the main hero, the sculpture. And how it all started, we basically started with a sketch. And it was quite like, at first we were surprised because we were planning to maybe try to print an arch or maybe, you know, something construction related. And then Elena Mikkelson came from the design factory in RTU, and they were like, hey, we really want a spaceman. Me and Maris, I remember, are talking like it's the worst possible shape to try 3D concrete printing. But then we thought, hey, we are a laboratory and university. We probably should do challenging things. And through this, we kind of wanted also to learn how to print more organic shapes, and sculptures are quite organic and hard to create. So these were the first sketches by an artist that we onboarded from Art Academy, Lauris Krause. And they were like, okay, this looks pretty good. Like the client, in this case, Liana and Elena from RTU were like, yeah, we really like this. Can you print it? We talked with Mars, but like, absolutely not, not in concrete. And then we started looking at ways how we can automatize that. And basically during this process, we kind of developed an algorithm that checks for the slopes, etc. So the set of rules Maris will later give you for 3D concrete printing, we have a way to check it automatically after doing the first sculpture, but we really want you to learn during the process. So at first you create your own slices, and then when we will evaluate which team or person wins the competition, we will use this automatic tool. It very quickly shows with red, etc., places where there are some mistakes that have been made. But how we arrived at that, basically, yeah, so we did it everything manually. So we first sketched these kind of division lines, where we put elements, how we connect them together. And at first we thought that we will connect the sculpture with tubes, but there were some problems with how to slide them in and how to make these 3D printed connections precise enough so it doesn't leave too much space in between them. Then we thought of a way where we basically put some rebar into the sculpture while it's printing, and then we use kind of these tensioning rods where we screw it and pull it together. And there were some iterations also how you can see that in the first sketches we didn't have these places for forklifts. But when you transport concrete, even a small piece, you usually want to also think about who will be lifting it, how you will be lifting it. And before starting up the concrete printer, we made quite a lot of these test prints in plastic. We actually used, I think, 2mm nozzle. So after conversions, it was really close to 1/10 of a nozzle that Mars is using on a concrete printer. So we were kind of using almost the same G code, like very, very much simplifying it, but at least the number of layers was quite similar. And here you can see like some of these tests. We also looked like how a person looks next to it when it's printed and assembled. You can somewhat also test the stability by trying to just flip it over. And here already we kind of optimized the files for the 3D concrete printer, and there was a lot of difference. Like when we imported, like at first we thought, hey, what's like we just use the same shape that we used for these test prints, but concrete is wet and it has some mass that is a lot much bigger than for concrete. And you can see even here on slicing, we already saw that there were some glitches like thickness-wise, etc. So kind of this conscious modeling for 3D concrete printing is something that we see a lot of concrete companies and startups that are attempting to do 3D concrete related research. That a lot of times they work with their own architects, so they don't like allow anyone to come in. They usually have their own either architects or kind of engineers who work with design, because it's quite important to design for printability. And you can see that the first shapes we tried to print did not go very well. Maris will go into details with that, and then we got a lot of comments and suggestions how to optimize it, and then the following parts already started looking better. Here you can see the inside, how we put the rebar, basically in order to kind of pull these parts together. And this is already almost ready sculpture. You can also see the shapes for forklift. It was quite heavy, I think. Well, I don't remember correctly. I think it's over a ton, definitely. We took this lifting device, and then we had issues with also its load capacity, so it couldn't go as high as we needed in some places. But overall, we ended up quite well. So it was already middle of winter when we were building it. we wanted to make it on time. Then we put it on ski and dragged it in the front of the place where the opening event was supposed to happen. And that is the part 2 where we are also already launching the event. So here you can see Maris already giving an opening speech. And like it was quite a lot of people. That day it was like a really snowy day. We were worrying if we will even be able to transport it because there was not enough time for the snowmobile to go through to clear the streets. But yeah, here you can see it. It's opened and welcome. Here's some close-up photos. This is Elena who decided who had the idea of needing a sculpture for RTU instead of a sample of a bridge or some other architectural element. And they are also part of our team. Yeah, this is basically all of our team. Maybe we will meet them later. And they also currently we printed a larger plastic shape that is this. So everything in the sculpture is 3D printed, even the this kind of sign for the authors. Here's a close-up of the material. For technical parts and all that, I think Maris will have a better input. So for me, I'm in my core, I'm an architect, so I'm more looking at design. So we are really happy how it turned out, especially for a first sculpture. But what we didn't know was how people will start using it after the printing. And then the first day we came, like we saw that someone already put a hat for it, and it's of course Elena's idea. And then we had a photo shoot with Krishna's Lab. And after that, there was Valentine's Day. And everyone, of course, wanted to make a photo with LabLab again. It has like this small band, and then this accessorization started more heavy. So yeah, Jani Festival came up, Labitsvar Festival, and it had a really nice and big crown. And after that, it was graduation, and so people had put a hat for it, so everyone knows that there is time to go for graduation. And there was a tennis championship, so it kind of became this place where people announce what is happening in the university. We also had some maybe less polite ones in winter from snow, so people started adding anatomical details to them. Lab. That was pretty interesting. Probably next presentation, I should also include that. It's very interesting. So winter is coming up. We will see what happens this year. And after that, also, yeah, the 1st of September, of course. So it had a nice bucket, but a nice this flowers for teachers and professors. And but we also noticed a lot of teams that come to Riga Technical University for like either to do an excursion, etc. It's kind of a place where people meet, take a photo. Maybe that's where they wait for a friend. And we would really love for the next one also to do it. But another point is that currently you can see that most of the times, like we kind of hold the thing while we take a photo, or if there's windy time, it flies off because we didn't really think about how to secure these elements. Like the hands are very simple. So that's something maybe to think about the next sculpture is how we can make it even lighter and easier to accessorize. And that's basically that. Like the fourth part of this today's presentation is for Maris, and Maris will tell us a little bit about how what's the technical side like. Because we just sent the files and the magic happened, and Maris printed everything with his team. But I suppose it wasn't as easy as I think it was. So Maris, welcome to the floor with the big round of applauses. We give you the microphone. I will also stop screen sharing so you can share your presentation.
Yes, thank you, Matis, for your presentation. Although it was quite quick.
You wanted it to be long.
No,
Nowadays,
I
it's the
think
format.
we will go back to the actual task.
Yeah. There will be a second part, of course.
I will show it also at the end of my presentation. And at the very end, I think we will have time for questions.
Absolutely. Yeah.
Because I think one of the questions could be, yes, okay, you showed what is the task, but how we actually want to see the result also could be one of the questions. Yes, I will start sharing. I will show you. I will try to show you. Okay. I will show you some details of the previous our lab printing. Starting with the dimensions. So although these were similar when we printed LabLab, Matis mentioned definitely in the first presentation that this is our second 3D concrete competition. First one was already 3 years ago. And but at that time, our printer was smaller. And Matis also referenced you to the video lectures that we did at that time. And I highly encourage you to look at those lectures, especially the ones that were by me, because there you will actually, maybe for those of you who are just starting the 3D concrete printing, there you will actually find the basics. As I will not talk about the basics today, I will especially talk about our LabLab design and how it can help you with the new LabLab design. But the basics of 3D printing, I highly encourage you to watch those lectures, as this is, yes, it will definitely help you with the design process. Because in this design process, you have to think about the technology and the material all the time. It's part of your design. And as I started this, so the print dimensions were smaller at that time. So these are the current ones. So we can print 1 meter in width and length, and the height of our object is maximum 1 meter. But I stress that this is a maximum, and I will get back to this in later slides, that probably won't be used that often. But the length and the width you can definitely use. So starting with, so Matis briefly showed you that the LabLab, so it's from several segments, because we definitely cannot print such an object in one go. The mixtures that we are using in 3D concrete printing, it's called 1K solution. So it's one component solution. That means that it does not contain any accelerator. Thus, the shapes that we can print are they are a little bit limited, because the concrete does not set while we are printing. It does not set after we have ended printing. Thus, we have a little bit limited shapes that are available for us, but we can solve it with other techniques. But that is something to take into account. And that's why LabLab 1.0 is designed from segments. And the new one will be definitely designed from segments. As you can see, it's not possible to print such an object in one go. And those segments need to be somehow connected. I will not actually show you the other ideas that we had and we tried while developing LabLab 1.0, but this was actually the most efficient, at least for such a sculpture. The method is that you put some reinforcing rods in each printed element around in the middle of your print, and you connect them with such a threaded U-shaped elements, which you secure with bolts here. What's the advantage of this method is that you don't have to be 100% precise when placing the reinforcement, and it allows you to apply considerable amount of force when you connect them. Thus, there is no free movement of yes, thank you. There is no free movement in between elements usually. Thus, this was quite a good method, but it has some limitations. Of course, there needs to be at least a hole in each element where you can connect it with previous elements. And during assembly, you need to have an access to this hole. That means that you cannot cover it with a top element, because currently the top element of our LabLab 1.0, like a hat part, it's actually glued on. It's not screwed on, which is considerable disadvantage of such a method. Considering that the new LabLab will not be, the segments will also need to be joined vertically, not only horizontally. I don't think that this method is the only method, and maybe even not the best method to use. Definitely check out my previous lectures to see what other methods people are using. But the main takeaway here is that this method has to be quite robust. So it's almost impossible to put a, for example, if we would just put a like a, let's say if we would put some bolt here, a bolt just in some layers, and in the next layers we would put some threaded nut. It's actually impossible to join elements in such a way. So your connecting should be quite robust, but also consider how to join such quite heavy elements and how actually to integrate it into printed structure, because you must also take into account that these elements needs to be somehow integrated while we are printing. There will be some later slides where we are just putting it in, inserting them manually by hand, but we need to do it quite precise. Thus, yes, there is definitely, this is one of key considerations that you need to take into account when designing. Next is the base. That could be also, well, it was definitely important for LabLab 1.0 because the element, the whole object is quite tall, and we wanted that it will not be possible to flip it over. So the base is actually with some reinforcement where the rest of the our pieces are attached to, and it's full of concrete, so it has a lot of weight. I think this is also somewhat important for the new object. I don't remember the full height, but it's definitely higher than the LabLab 1.0, and it has quite a bit larger head, and it's definitely quite a bit of mass on top of the object. So it also probably needs some weight at the bottom. This is also a part of your design. It's not just splitting, it's also thinking about the structural integrity of the object. So how it will actually, because for example, if you would leave all the elements empty on the bottom, but for example, head would be full of concrete, then probably this element would just roll over, as there would be some misalignment and it would be too heavy at the top. So this is also something to think about. Here for LabLab 1.0, we used a pallet jack. So we are still able to move this object around the campus with just a pallet jack. It's really easy. But for the new LabLab 2.0, it's not necessary, and I would say it's even definitely don't use such a method, because at the place where it will be located, we will not be able to go with the jack over there. So everything needs to be brought to the site either by hand or with some crane equipment. So as Matis told, this is also one of the your tasks will be that will go into details at later stages. But anyway, while splitting, you also need to think about it. That of course, if the object just is from the whole object is just from 3 pieces, each piece will weigh, for example, 1 ton. You will need quite heavy, quite a large construction crane to move it into the place, and that will not score you high in the category of ease of assembly definitely. So you need to think how it should be as light as possible, but as structurally integral as possible, and as easy to connect as possible. That's the idea here. So regarding some specifications and how, yes, if we think about reinforcement, these are good examples what could be okay for draft versions, because you will have several draft versions of your proposal that we will go through. But for the final design, definitely there should be exact locations where, for example, reinforcement needs to be located, where the connecting elements needs to be located, if there is enough space for the connecting elements, because these were questions that we had during the production of LabLab 1.0, and they were not solved at that point. Not all of them. Thus, we would like that during printing of this one, there would be at least good design. So it's quite crucial to be precise about this. But as I'm writing here, it's okay for draft version, of course, because you will have some draft in maybe even 1 week will be the first one. So of course you will not be able to design perfectly where you want to place the reinforcement, but for the final design it is crucial. So about reinforcement itself, so in the context of our object, I would say that there will be probably 2 kinds of reinforcements. One on the left-hand side is the one that I already talked about. So it's these are some reinforcement bars that are integrated in each element that could be used for connecting or at least lifting the parts. Probably these will be in most of the objects, they will contain such elements, but maybe not. It depends on your chosen connection type. And second type of reinforcement is these ones that are in some critical points. So the idea is that from structural point of view of an object, it's also crucial to think how these objects will live, let's say, live the life of their own until the moment they will be assembled. Because concrete itself, if it's not reinforced, it's quite brittle. So you need some reinforcement. So if you have such an element as here, you can see this infinity sign, you need some reinforcement here in the middle to actually, so the object does not crack and break into 2 parts. So such additional placement of reinforcement is really I assume it will not be possible for all of you, because probably not all of you are studying civil engineering or have some experience about concrete structures. But you can get quite a lot of details from my lectures and online. But this is definitely something for students to think about. This is not be necessary for some of the elements in the print. So regarding a little bit about our printer and its capabilities, regarding layer heights. So each object can be printed in different layer heights, but as one of the key criteria is the aesthetics of the object, I would say probably, I think that it might be needed to print all objects from the same height, but it's actually up to you. You can say that you might need this change of layer heights because maybe some elements are needed more detailed than others, because of course if you print with layer height of 5 millimeters, you can definitely get much more detailed object than with layer height of 15 millimeters. maybe it is necessary, because the final print, of course, is really dependent also of the layer height. But what we are usually using is a layer height of 10 millimeters. That was the one that was used for LabLab 1.0. And for such an element, such an object, I would say it's optimal. But as I told you, it's up to you. If we print with the lower, it just takes significantly more time, and we have to do it with the nozzles of smaller size. That means that we might need several layers that are next to each other to actually the object to be structurally safe. So it's a question. I would go with 10 millimeters, but we can discuss this if some of you have will have such a question. We can maybe think about it in some later lectures or consultations. Here, one thing to note is that the diameter of the nozzle is not the line width what we are printing. So if we use the 10 millimeters of the height and 25 millimeter nozzle, then we can. That actually means that our layer width will be around 40 millimeters. That is something that you definitely need to take into account when designing. So each of these nozzles, if we print with them, so here it's just around 1/3 of the nozzle diameter, or around a half. You can add like some 50% of the nozzle diameter, and then you will get your width of your print line. So if we use smaller height, we need to use smaller diameter, and it will produce smaller lines. So for example, 10 millimeter will produce some 16, 17 millimeter, 15, 16 millimeter line width, and that is not actually for object is probably not enough. So continuing about some local overhangs. So an overhang is actually something that we try to avoid. As I told you, the material is not setting fast, so we cannot do these intricate shapes where we can have some 70% overhang. The material is still wet while we are printing, but we can have some of it. So generally, it could be okay for around 8% of such an overhang to be there. But it depends from an object on object, but this is something that we could aim for. We can look at it also during some consultations if you have some object where you need it, and maybe there are other ways how to actually solve it. But here we also must consider that if there's an overhang, there is something that is also allowing it structurally to be there. So it's not a straight line, because straight lines are not, the object would not stand here if the overhang would be on a straight line. So also this curve definitely allows it actually to make such an overhang here. If we talk about straight lines or some, so this object is from our the first concrete competition. Maybe not the best photo because you cannot see that this part is actually sloped. Here is a slope of some also 8-10 degrees. And the idea here that actually these supports allows it to be inclined a little bit. So this is one of the ways how you can solve it for larger elements. If you need some incline, you can solve it with such supports, because if you would just infill, of course, I will show you the next slide. So other ways you could just use an infill, but that's not an innovative use of this material, because then we would waste a lot of material. It would weigh a ton, and it's not even possible to put some connection elements. So you need to have some kind of supports probably, and also if you have straight lines, long straight lines, you definitely need some supports, because while printing they will also not will not be dimensionally stable, and it will just collapse while printing. So if you have, although this object by itself does not have any so straight lines, but maybe there are some elements I haven't actually looked into how it can be split. So maybe there are some straight lines, you definitely need to support them. So yes, here we can see some, call them global overhangs, or let's call them incline. Here it's solved with a lot of infill. So it's possible. Here are like 45 degrees. These are the legs of the LabLab 1.0. Yes, we can do it that way. This is probably one of the only ways how to do. For example, hat of LabLab. It's fully filled with concrete. There are no other ways. How can I? Well, there are technically other ways, but it was the most efficient way how to print one element that is needed to be a dome. So of course, during such elements, there might be this might be the only solution. So this is possible, and you solve it with an infill, or yes, support, but here it's more an infill. Regarding the infills, so this is actually somewhat already quite detailed into the objects themselves, because at the first you will maybe not think about how you will make your infills. But let's say for more advanced objects, and for those of you who want to go in this direction, if you are thinking about infills, then from printing perspective, it's really important to have lines with maximum length, because if printer needs to make such short lines, it stops every time, and its extrusion stops. And when it needs to stop and restart, the flow is not the same as extruding long straight lines. So this kind of grid really messes up the object. It does not come out of the concrete printer like this. This could be okay until we go to these small parts. The printer would need to stop, restart. This is bad. This would be more or less okay if not for the ending and starting. And again, the problem is maybe if it would be in the middle, no problem. But here, at the very ends of the object, thus there will be some problems here. Maybe probably some underfilling. If you have these concentric lines, okay, maybe there will be some. Not sure how this object will turn out. Maybe okay, maybe not. In this way, you have even lines. And what is crucial also, because there is some over extrusion or under extrusion each time. So if you have such a print, there might be that if you are able to see on this straight line what's your infill pattern, because a little bit there is some over extrusion, there's a bump here, there is again bump in the next one, and the object is not, this line is already not straight. Here definitely there would be like, you would be able to see. Here it's even material deposition along the outer perimeter. So if there is some over extrusion, it's even for the whole perimeter. So this is one of the best ways. Maybe there are some cases where you need different infills. It is possible, not saying that this is the only one, but that is from our perspective as printing. Regarding the object height, as I told you, in z-axis, we can go up to 1 meter in height. But as repeating myself, we have 1K solution. That means, and we don't have such. So with 1K solutions, you can print higher, but our print bed is not big enough, so we can have several objects that allows this material to at least a little bit settle, so we can start printing it even higher. So we are a little bit limited. So what's our, let's say, manageable limitation? So we could say that height of our object, 30, 40, well, 30 centimeters is really okay. So manageable here, it means okay. Challenging, it is challenging, but it is possible. It's not impossible. But the challenge goes that if we want to make this, like, if we want it to be good looking, then it's challenging, because you need to have the consistency the same. So as we know, we need to split these the object in smaller pieces. Each piece anyway needs to be somehow lifted. So if you can stick to these limitations, these are the best ones. So 30 centimeters, if all objects would be like that, perfect. Because we can go higher. For example, here is we have printed 1 meter object. Well, it took just 7. Well, in this case, the 7 hours was just experimental time. It's probably possible to do it faster, but it's possible to print it. But here, the material is not the same for, well, the material is the same, but it's different mixtures, mixing batches. Let's call them mixing batches. So each time the printing restarts, there is one line that actually shows where you have restarted your printing. Thus, it is possible to print also 1 meter objects, but usually if those objects are in the dimensions that are needed for this lab, we will not be able to even leave them out of our print bed. So probably not needed, and definitely not ideal for us to print. But if some object you think needs such a method, it is possible. Not sure if it will score the highest in some ease of assembly or innovative use of this technology, but it is possible. So when you think about the objects from segments, we also need to think about that it will be possible to see where these segments start and end. At least from some perspective, it will be possible. Thus, what Matis already showed while designing the LabLab 1.0, the artist took this into account. So he especially made these, let's say, segments of the torso of the object that the viewer doesn't really understand that it is due to the technology that it looks this way, but he somehow integrated this into the object. I have one picture here. So you can see here, so this is one segment and it ends here, and it's somehow like it looks like a little bit stacked, but so you can see here, and this is one object, but as the dimensions change here, you are not actually able to see here. And this element, for example, it's printed flipped, because as you understand, for all the prints, most of the prints, well, or all, you have to have one straight, so you have 2 planes of it will be straight and parallel to each other. So how we can print such an object without, so it's not possible to print in this direction, we just flip the object. And this part, as I told you, for example, this is complete dome, so this is completely filled with concrete. So, but in this case, it's just glued on top, which I would not recommend for this object to be the case. I would definitely try to think of a better solution. So there are some disadvantages with this solution, but if you are creative enough and you think about it during your splitting and during the design, this can be solved. I'll come back, yes, to the conclusion. So the same things that I already explained, our dimensions, plans for connections, optimum print line width and height of 40 millimeters and 10 millimeters height. Try to limit, well, yes, the global overhangs. Of course, it will not be possible to limit them because the object it's not a square. It has some overhangs, but think about how to limit them. I will go back a little bit to the task. So, because Matis was quite quick with the task. So once again.
Oh, you have it. So nice.
Yes. So although the task is so offer the most efficient split and assembly solution, the split part is actually, I would say, well, an assembly. It's not just splitting. So what you are thinking about? You already heard that things to consider into in my presentation. So the split, you need to think about how to actually the object will be printed and how it will actually perform when it will be connected. And you need to think about your material efficiency. That means that, of course, we could fill all the lab with concrete. So, for example, one solution is just to print these segments, put it together with some additional wooden construction so it stays in place and just pour concrete fully inside it. But that's definitely not materially efficient and ease of assembly. It's definitely not easy. Thus, you need to think of these solutions also beforehand, before you split and in the same time. So here it's also feasibility, stability. This is something that I already also mentioned. So if you will have a lot of weight at height of 3 meters, but the actual foundation of it is really small, and then you can have some problems with stability. So think about it. And creative additions. That is also something we highly encourage. So right now the object itself is just, well, it is just a 3D concrete printed sculpture. But as you saw, the LabLab 1.0, it is definitely, when we printed it, we definitely didn't think that it will be used as often. So as Matis told, every time a guest comes to university, they try to make a picture with LabLab. And all the various accessories it gets during various yearly periods in university, as the hats and all the equipment that it might be holding. Maybe think about it, how such an, maybe the hands of this new LabLab needs to have some holder where we can actually put some, I don't know, flag or any other object that needs to be at that point, because it's definitely will score you good, better at creative additions. And some ideas like maybe some illumination needs to be there. Matis also mentioned, can you combine with polymer printing? So specifically, maybe there are some parts that should be printed with different material. I don't know. I haven't thought about it yet, but maybe there are other techniques that could be really useful, but for this small part. it's up to you. You are not limited so much because what we want here, we want creative solutions, so we can choose the ones that are possible. But if you will just limit yourself of what we have said that is possible, then we will not get any new ideas. So you don't need to limit us. You don't need to limit yourself with just the straightforward 3D printing. Definitely think of some extra creative touch you can give to this object. And yes, thank you. This is for the now. It's all from my side.
Oh, super. We also have that's an applause. I thought question. We will have time for questions. That's a very, very important point. And we are super on track. I will go through the kind of close-up slides, and then we can continue with the question part. If there are any. And also, if you already have the question, you're afraid to forget it, just write in the chat, and then we will either give you the first opportunity to speak, or we will just read them out and we will answer to them. So some of the questions you will answer have from the follow-up slides, I hope. It's about what's happening next. And here we go. So yeah, this is where we were. I will quickly check. Is it the yeah, okay. So currently we are at this part where we kind of do the competition part, and after that we will have kind of this test prints and concept validation. But the competition where you are currently is a 3-month competition, which will be finalized with the best design, which will get the prize. So definitely remember to join the WhatsApp group and Facebook group. That's important. And if you don't have the links, ask us. We will send directly. So for the next meeting, basically, we plan to have a kind of concrete split draft review with mentors, and which basically means that you have 1 week time to download the 3D model, which we have here, and we will basically meet with you next time and then show and kind of evaluate. So you don't need to create a super detailed 3D model. You can do either a rough cut, like just blocking out shapes, or you can do, for example, a sketch or a drawing, like you saw, like Maris said, that's not a good final drawing, but it is fine enough for now. And at that point, we will give you some comments, and so your final work will be better. So in total, we aim to have approximately 4 to 5 meeting points. You also can have a chat. So if at some point you don't understand something, you can definitely ask. And now I will show the other presentation, because I think I showed you the previous one. 1 second, I will quickly check. There are 2 very similar presentations. Yeah, this is the right one. Here we go. And the next workshop is Monday at 6 o'clock. So I hope you have the time. It will also be recorded. Yeah, I will reshare the screen because I opened the new one. I see the comments also are coming in. We will quickly switch those. So yeah, next workshop is next Monday. And your task will be to do a draft design for splitting concrete elements. We also have some other upcoming lecture topics in further, so modeling for 3D printing, covering these topics and how to split and connect and engineer and consult you, and who will be the speakers. I think one of the main guys you haven't yet met is Slava Markin, who is from business development and manager at Sika. Sika is a really great company, and we also have some others hidden in our sleeve. So you also will be hearing from international experts. But to prepare for that, definitely try to do the first quick sketch or cut yourself. Of course, if you can and if you have the competencies, it's always better to work with a 3D software. But if you can't, then one option we also have, you are not prohibited to create teams. So basically in this WhatsApp chat, you already see the participants. You also see them here in the Zoom call. So if you have some request, for example, maybe you're a good designer, but you don't know that much engineering, you can combine your efforts to have a higher chance at winning. So that's up to you if you want, but you all register individually, but during the competition, it's like, in these survival games in Netflix that you can join teams but yeah, when we give the prizes, of course, then you will have to probably split it with your teammates. So that's some kind of interesting dynamic to think about there. And I think that's mostly it for today, but we can go to the questions and answers section, and also maybe Maris will also have some closing comments. So from the questions, we have 2 in the chat. And the first one is, what exactly is the shape to be printing using concrete material? Yes, so in the chat, we have sent the link to a folder where there are Blender file and object file. It is basically the concrete sculpture which you recently saw on the screen. I will show it here again. So this is, if we could print it, if we had like 3 component materials, then this competition would not be happening. We would just print it, but we are using 1 component materials, and it's not something because we can't. It's more also about intentionality, because 1 component materials are really sustainable. They are quite more affordable. So if we figure out how to reliably print in parts and design for splitting, then we can very efficiently scale up and be very competitive in the market later. So it's a good skill to acquire. And that is the shape that you need to divide. And the files are in the chat. If you don't have them, then ask it. But so it's WhatsApp chat, not this Zoom chat, but the WhatsApp one. The other question I have some printing concrete. How can I? Yeah, so if you haven't registered, Anil, then definitely register. And then basically, yeah, if you have some experience, very good. You have increased chances of winning. But we also, if you're a student at RTU, in WhatsApp, you can see my contact. We have some projects. That also actually goes for all of you. If you are actually not here only to design, but you know you want to get your hands dirty and try some printing, then me and Maris are very welcome for this, and then we will definitely find you a way how to touch the concrete too. So this is of course design competition, but practically, of course, we work with the 3D concrete printing, and if you're interested, reach out and we will get in touch with you. Yeah, registration for this competition ends this midnight. So if you haven't registered yet, absolutely do it. So we currently have enough participants, but you know, we can always have more. So yeah, I guess that's from my side everything. I'm saying thank you to all, but maybe Maris, do you want to do some closing statement, best wishes to everyone?
No, I was waiting. Maybe there would be some questions.
More
maybe.
questions? You can ask question yourself. I can ask you a question. Hey, Maris. So basically, we are printing with 1 component materials. Yes. So how would, in percentage wise, how would that, like 1 cubic of standard concrete, like not calculating mixing time and kind of all this kind of preparing the printer, but just 1 cubic meter of traditional concrete and 1 cubic meter of 1 component material. If we buy in Latvia, approximately how much percentage increase we are looking at this 1 concrete material compared to? Of course, you will ask what type of standard concrete, but like just to have an idea. But is it 2 times, 10 times, 50 times?
It depends. It depends, Matis. What amount you are buying?
1 ton.
1 ton from a shop?
Yes.
You cannot buy, but you cannot buy this material in shop. So
okay,
here lies your first problem. Here lies the first problem, is that you cannot buy the material in shop. So you cannot buy it in small quantities.
What is a big quantity?
Well, something that at least a company is interested in mixing. Okay, 1 ton is probably the smallest amount that they can mix for you in dry mix concrete. But yes, so and that would be your main price would be that somebody needs to deal with 1 ton of material. Okay, that will increase your price a lot. If we think component wise, if we talk about some theoretical future, because probably, well, it's a question. Do you have this question for today or for future? So the material does not contain. That's why you said it correctly. There are no accelerators, and the additives themselves don't account for so a large percentage. Thus, from the point of view of the dry mixture, it's not the raw materials themselves are not that expensive. But then the main question of the price is mostly related to what you are using it for, how much do you want, what kind of certification you want for it. So as you said correctly, and that's why I think it is interesting to print with these 1K solutions, because yes, we could a lot of these problems can be overcome with 2K solution, but then also it does a lot of engineering problems goes away with these 2K solutions, but a lot of problems comes back mostly due to price. But there could be some limitations where you can use these materials if all of them can be used in Latvian weather, maybe. Well, we have to see. We can definitely use this material. This was actually one of the aims of LabLab 1.0 is actually to see how such a material does behave in a Latvian winter conditions, and it behaves really good. Not sure about all 2K solutions. And of course, for example, in 2K solution, how you would insert, well, probably you could try to insert some reinforcement, but the material sets in minutes. So also you have to be really fast.
The layer times, etc. Yeah.
Yes. So yes, but that's mostly why we are using it. Probably it will be the material that will be used mostly for 3D printing. For most of the volume, let's say, yes, for such like a fine objects, of course, there could be best also 2K solutions are usable. But yes, the price depends. But yes.
Okay, so we have another question came in, and this time not from me. So what materials are we going to use in printing? So you already said that previous LabLab we printed from this dry mix mixture. So in this case, I understand that you are doing some new material, yes?
This is really good question. Thank you for the person who asked this question. So actually, that we mentioned in our previous lecture. So this competition itself is actually a part of one scientific project that we are the Riga Technical University's coordinator and main partner of. So this project is called Transforming Waste into High-Performance Cementitious 3D Printable Materials. It's funded by European Union by a project called Emeranet. And in this project, so it's a three-year-long project, and we actually just started the second year of it. And in this project, we develop new types of these cementitious 1K solutions. So 1K just means that there is no accelerator, but there are several components of the mixture. It's just more or less based on ordinary cement. But here in this project, we substitute a large part of the cement with waste material. In this case, mostly it's oil shale ash. It's an ash from a power plants in Estonia, because Estonia is rich with oil shale. And they are producing electricity using oil shale. Oil shale is a mineral. It's somewhat similar to coal, but it contains significantly higher amounts of calcium in it. So it means that when you burn it, you are left with 50% of, if you burn like 1 kilogram of oil shale, you are left with 500 grams of ash. That's a really, really high amount. And thus, they need a way to use these ashes. There are some of the ashes that are being used in regular concrete industry, and some of the ashes that cannot be used. As the technologies are changing, also the CO2 limitations for the power plants are changing. So the ashes are changing, and the way how to use this ash is actually in some new types of concretes, and 3D printable concrete is one of those materials. So as for this project, the idea here was that here we develop a prototype object that we will print next year, and that will actually allow us to test how our developed materials actually perform in Latvian winter. Of course, we are making all the laboratory testing that to know that these materials are safe, and that we have quite high chances that they will survive Latvian winter. But anyway, you need to have these on-site testing to actually show that your lab measurements are in accordance with reality. So the material here will be highly innovative. So this type of material definitely is something that will not be printed and exhibited before. So it's also your chance to actually, it's not a regular 3D printable concrete, it's sustainable with high percentage of waste material. So this brings also some innovation to this competition as well.
Okay, thank you. If we have any other questions, then this is the last moment to ask. If not, I think this is what concludes our today's meeting, and see you all next Monday. And then remember to start working in your designs. And the next workshop will be organized. Basically, there will be no presentations from us at this point, but we will ask you to provide your designs, and then we will comment them. And after that, we will have another lecturer from abroad who will start looking at your designs. But first, you will be able to consult with us, so you feel safe and prepared when you go to them. Good luck to everyone. That's the most thing. I believe everyone, you have a real chance to win and become a 3D concrete expert. Okay, thank you and goodbye.
Thank you. Bye.